WPR number 7. I'm going to solve this quadratic equation by completing the square. When we do that, we have to have a leading coefficient of 1, so I'm going to go ahead and divide everything by that 2. And then I'm going to go ahead and clear out that constant to the other side. Next, I'm going to take half of the coefficient of the middle term and square it. So I'm going to take half of this and square it. So half of it is 3, squared is 9. That's what I'm going to add to both sides. Now I can factor that perfect square trinomial and rewrite it, and rewrite it as x minus 3 squared, which then allows me to take the square root to get x minus 3 equals plus or minus square root of 7, and lastly I can add that 3 to the other side, so I have my roots 3 plus radical 7, 3 minus radical 7. When working with negative exponents, we need to move the base that's being raised to the negative exponent. So in this example, what I'm going to do is go through it and look at each of these things being raised to a power and ask myself if they will stay or move. So I set up my fraction bar, and now I look at each of these. Well, the 3 is not raised to any power, so it definitely stays right where it is. But this x is raised to a negative power, so I'm going to move it to the denominator, which makes the exponent positive. Lastly, in the numerator, I have that y to the 5th. 5 is positive, so that y stays right where it is. Now, in the denominator, this whole thing is being raised to a negative power, so I'm going to move that entire thing, which makes the negative 2 positive. It doesn't change anything on the inside, but by moving this to the numerator and making this exponent positive, I can now square these. So I will have 3y to the 5th on top, x to the 4th on the bottom, and when I square this, I'll have 2 squared, which is 4, x cubed squared, so I'm raising a power to a power, I multiply those exponents, and y to the negative 7 squared, I multiply those exponents, now I can go back through and clean this up a little bit. I still have my fraction bar. I still have a 3 on top and a y to the 5th on top, and a 4 and an x to the 6th on top. I have an x to the 4th on the bottom, but now this y to the power of negative 14 will move to the denominator as y to the power of positive 14. I can do a few more things here. I can multiply the 3 by the 4 to get 12. I'll put the variables on top in alphabetical order. And now I see that I can divide those and those. When I divide the x to the 6th by the x to the 4th, 6 minus 4 is 2. So I'll have 12x squared, and when I divide the y to the 5th by the y to the 14th, I'll have a y to the 5 minus 14 is negative 9, but I should rewrite that as 12x squared over y to the power of positive 9. I have a higher degree polynomial that I'm going to factor and solve. Higher degree means higher than 2. So it's not quadratic. We can't use a quadratic formula. We can't complete the square. But we have 3 strategies we can use when we're solving a higher degree polynomial. The first strategy is to look to see if we can factor GCF out of each of the terms. In this case we can't. This doesn't have an x. The second strategy is to look to see if this is a difference of 2 squares. No, that's not a difference of 2 squares. It has 4 terms in it, and we can't take the square root of all of the terms anyway. Lastly, we look to factor by grouping. So I'm going to take a GCF out of the first two and the second two terms. The GCF of the first two terms will be 4x squared, and when I divide 8x cubed by 4x squared, I would get 2x, and when I divide 4x squared by 4x squared, I get 1. Now from these second two terms that begin with a negative, I'm going to factor out a negative and a 9, and negative 18x divided by negative 9 is 2x. And negative 9 divided by negative 9 is plus 1. Now I can see that I have in these two terms a common factor of 2x plus 1. And when I divide a 2x plus 1 out of this, I'm left with 4x squared. And when I divide a 2x plus 1 out of this, I'm left with minus 9. I can apply the zero product rule, which states that if you have two terms that are being multiplied together that result in 0, that you can set each of those terms or factors equal to 0. So here, after I subtract 1 and divide by 2, I'd have negative a half. Here I would have x squared equals positive 9/4, and when I take the square root of both sides, I'd have plus or minus 3/2. So it appears that my answers are plus or minus 3/2 and negative 1/2. I'm looking to factor, and the first strategy I always try is factoring out a GCF. Each of these terms has an A, so I can definitely factor out a GCF of A. What about a coefficient? No, 10, 23, and 5 do not have a GCF. So it looks like for this problem the GCF is just A. So now when I divide this by A, the 10ax squared, I'll be left with 10x squared. When I divide the negative 23ax by A, I'll be left with minus 23x. And when I divide the negative 5a by A, I'll be left with negative 5. Now I'm going to try to factor again this 10x squared minus 23x minus 5. Maybe what I'll do is I'll carve out a little space for that here. Okay, I'm going to try the AC method, or tricky trinomial. So 10 times 5 is 50. And I'm going to list factors of 50 until I come across something that will give me a 23. It just kind of occurred to me right now that 2 and 25 would work. So for this 10x squared minus 23x minus 5, it looks like I can write that as 10x squared minus 25x plus 2x. So the minus 25 plus 2 result in this negative 23. And now I factor by grouping. Okay, so these aren't the final two factors. Remember, I've got to go back and put that back with the A. Now I'm not setting these equal to 0 because the directions did not say solve, it just said two factors. So this is the answer. This is a complex fraction, and we know that when we simplify a complex fraction, we are going to multiply every term in the complex fraction by the least common multiple of each of the denominators. So I'm going to need that and that, which would be the same as both of those. So I'm going to multiply every term by a plus b and a minus b. You may have noticed that I have already factored this. It originally was a squared minus b squared, a difference of two squares, which I factored into this. I'm going to do one other thing here, which is add the opposite, because I don't like subtractions in these problems. Now I'm going to go ahead and rewrite. So like I said, I'm going to multiply everything by a plus b and a minus b. And now I can cancel. So I'm left with the 5 times a minus b plus a negative 5 times a plus b over 10. I can go ahead and distribute the 5 and the negative 5. And now 5a minus 5a is 0, but negative 5b minus 5b is negative 10b, which results in negative b.